what makes for a good AI platform?
I think what we start to see is that this is becoming, if not a tool of science, a partner in science. And my friends at NASA, they call a lot of these AI tools the idiot savant. And I laugh. I said, "What do you mean?" They said, "Well, it allows me to iterate so much faster." Like the Harvard study just came out, 40% fast, improvement in productivity. But what you do is you take the output from AI that I'll be building with Dimitri and the team, and then you use this in the good old-fashioned in situ and the things they've known for years in data science and whatnot to validate and test. And if we do it right, you can dramatically shorten the search space by orders of magnitude. And that to me is so exciting. And I think, Jake, if you look at where we are today with foundation models and the techniques, it's very, very early. It's only about 8 months into it so far. So if you look at the history, a lot of the biology, you work with maybe a sparse data set, and you have sort of markers, and you do sort of correlations and basic, logistic regression for many years drove a lot of the insights. If you take that and start to think about, well, what about other modalities? Right. And so the basic idea of, fitting a curve, fitting a line, logistic regression, and that was done with markers. But now think about what about sequences themselves? And how do you represent a sequence in basically a vector space? How do you look at images? How do you look at other things you get from the lab? And now you're doing the same sort of math, but on richer data sets. And these data sets tend to be rather large. And so that allows you not only to find these relationships, but once you understand the language, you can then turn around and do synthesis as well. And so that's sort of the natural evolution. So if this seems a little foreign to you and maybe exciting, but that's kind of the basic science that we're seeing, is you're just sort of extending the modalities. But now we have what people used to call hyperscale AI. We're seeing it now with these large language models, large protein models, LPMs, for example. And that's really exciting. And I think there's a question you saw in the Q&A. People said, well, how do you know about, if you have all the things we've got for all these different proteins and molecules, what about rare molecules? And what we're seeing of some of these larger models is these emergent properties, where it starts to grok and understand the language of life itself and make internal representations that we can use for statistics. And these internal representations start to have capabilities. We can now infer things that we didn't really see before. So we saw that in human language, where we train models on, let's say, the top 20 languages, but a language like Japanese wouldn't have a lot of sample data, right? Because it's a very popular language, but a small population. We're able to translate Japanese because it started to understand the human language function. So I think that's really exciting. I'd love to work with Dimitri and the team and learn from both and the team here to say, as we start to understand molecules and proteins and the structure, are we going to start to see emergent properties as it's starting to be a real partner for us in the tool of science?